Hi friends, welcome to follow up. In this video, we are going to practice problem 1669, merge in between a linked list. So we are going to provide two solutions. One solution, we are going to work with general the vanilla Python list, so that we can do a build for linked list. For the second one, we are going to manipulate the linked list themselves. So with that said, let's quickly look at the problem statement. So here we are given two linked lists called list 1 and list 2 of sets n and m respectively. So we want to remove list 1's nodes from the a's node to the b's node, both inclusive, and then we put list 2 in their place. So here the index is zero indexing, right? So here for this example, basically demonstrate what's the operations, right? So you can see the first example. So here the index is 3 and 4. So here I have index 0, index 1, index 2, and 3 and 4. We are going to remove these two nodes, and then so we connect 13 with the head of list 2, and we put the 5 to be the next after the tail of the linked list 2. This is basically the general logic. So here the constraints are the following. First, the length is bounded by 10 to the power 4, and a is at least 1. In other words, we will not delete the head node. So actually, as you will see in our coding, even a is 0 is still okay, right? So, and b is strictly less than, and b is not the last node, in other words. So here, the length of list 2 is also bounded by 10 to the power 4, right? So with that said, we can first look at the plan. So method 1 is going to work with Python list, right? In other words, we do not work on by way of this list and then build a linked list as the result requested. The second one is working directly in a linked list, or working directly with the linked list. So now let's look at the method 1. So work with Python list. This is actually very simple, right? We can first get the list corresponding to the two linked list, and then we can do the deletions, right? So this is actually very straightforward. So for example, we have list 1, list 2. So let me do things like this, and then we can use a for loop or write a function to get the two lists. It's actually very simple. Well, list 1. In other words, this head is not empty. So what we can do is we get the corresponding value of the current head and then append it to list 1. So let's do list 1 append list 1 value. So this operation is valid because list 1 is not null. So once we done this, we can push the head to the next. Right. So after we exit this while loop, actually we get the corresponding Python list for linked list 1. So we can do the same thing for a second. So I'm going to change this one to be 2, and change this one to be 2. So here, list 1. Let me distinguish this one. So list 1, yeah, this is right. So I'm going to list 2, list 2. And then actually we want to build the result, the corresponding list for the result. So this is actually super easy. The list will be, so list 1. So because we only pick this one, not including a, because a is to be deleted. And then we add list 2, then plus list 1. So starting from b plus 1, so we have this. So this will be our list, and then we can build a linked list. So this is actually very straightforward. What we can do is this. So we can use a dummy index. Let's call it list node. So and that's maybe specific value -1. So then current is dummy. Then we can use a for loop. So for element in list. So this element is an integer, right? So we can set the current next to be a list node with the current value, that is element. And then we are going to move current to current next. So this way we will build the result, and then we can just return dummy next. So here we are using dummy index, so which is a very routine treatment in doing problems related to linked list. So this way of doing this problem is rather straightforward, or in other words, we by way of the Python list, and in fact we didn't treat using operations operated on the linked list. But let's first test it. So here list node don't have attribute append. So here list1 append list1 value. So list1 append list1 value. So list1 append. So here, yeah, I guess this is a list. Non-type has no values. List2 append. So here list2. Right, let's change this. I guess same thing here. List. This naming is not too good. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So now let's look at our second solution. So actually from this version, I want to remind you that use good naming conventions. So here, let's see, I want to distinguish list1 and list2, but I just missed I, right? This is actually very error prone, but let's contain ourselves here. So next we are going to copy this one. And I want to do it directly using linked list operations. So work with linked list. So here the idea is very simple, right? So in order to remove this part, we need to get the node before A, right? And node after index B, right? Then let's call this one let's call this one node A previous, right? And let's call this one B after, right? Then what we want to do actually is we set A previous next to be the head of list2, and we set the tail of list2. Let's see, its next to be B after, right? So that's our plan. So, and in order to get this, actually it's rather straightforward. Essentially, we do a linear scan like in the first version. So what we can do is this. So first, I'm going to use a dummy list. So this is not necessary, but I want to treat it like this way, and we connect this dummy node with respect to list1. So this way, actually, I can treat the case if the index is A is 0, right? But no, notice that here A is greater than or equal to 1. But I want to say we can treat the case even A is 0, or even B is the last node, right? So with that done, so we are going to first locate A previous and B after. So this is very simple. So we can get a current is list1, current height, and then we use a count or index variable. Then we set A previous and B next to be none, and then we are going to set it after we do the while loop. So we just need to make sure we iterate up to count less than or equal to b plus 1, right? So the b plus 1, the index corresponding to the node after b. So this we want to see if count, let's see, equals a minus 1, then we are going to set a previous equals current, right? Then we check another condition. If it equals b plus 1, then we are going to set b next equals current. So if the two conditions are not fulfilled, then we are going to do the count by 1, increase the index, and then do current equals next. In other words, we can think of this count variable as a pointer, which points the current state of the current variable. In other words, the next of the previous current. So after this while loop or this linear scan, so we are going to locate this one and this one. Then what we want to do is so the next we want to do is to find the tail of list 2. So it's actually also simple. So we do list 2 tail. I set it to be null, and then we from beginning list 2. So while tail next, right? So we can push tail forward. So tail will be tail next, right? So after we exit this while loop, due to the way we write the condition in the while loop, tail next will be null, and tail will be the genuine tail of the linked list 2, right? So then we can get the current state of this tail. So what we want to do is reset. We reset the previous next to be list 2 height, and then tail next. So this tail will be the genuine tail after this while loop. So it will going to be the b next, right? And then we are going to return dummy next. So as I mentioned, in this problem, we don't need to use the dummy node trick, but here we use it is to make a remark that if here a is 0, in other words, even we can delete the nodes from the beginning up to certain points, or even we can delete the whole list. That will still okay. So we can do this trick. So this actually is essentially the same thing as a solution V1, and especially they have the same time complexity overall. But this one is more intrinsic to the problem because we are working with linked list. We prefer to do operations in the context of linked list. Before we make some further comments, let's do a test. It passes one test case. Now let's look at the generic case. It passes all the generic cases. I would say for the linked list data structure or data type, there are quite a number of problems in leetcode. So basically, it has types like delete a node, or connect linked list, or reverse some nodes. So those problems can be typically solved using the same idea. And sometimes you can think of the dummy node trick, and also you can think of the two pointer or pointers trick. So with that said, I guess that's about it for the current video. Thank you.